Welcome, ladies and gentlemen. Today we're going to talk about solving exponential equations. This is the reason why we've learned how to expand exponents and logs. So you will need your notes, a calculator, and a pen and/or pencil today. Here we go. So to solve an exponential equation, we need to know our properties of exponents, and we need to know how to change into log form. So for this one, since my base is 2, it's going to be log base 2 with my value of 16 equals my exponent, which is 4. It's also very, very important that we know how to change e. So when I have e to the 5th equals 148.4, e is going to turn into ln, okay? And that's my base number. The number that comes next is going to be 148.4. And that's going to equal my exponent, which is 5. Also, which is very, very important to remember, we need to know the change of base formula. So if I give you log A of B, this is going to turn into log B over log A. And that's what we're going to type into our calculator. So some very important things we need to know before we start solving. All right, there's 2 different types of exponential equations. So make sure you get this written down in your notes, please. With exponents on both sides and with exponents on one side. So we're going to deal with 2 different types here. We're going to have both sides or on one side. So with exponents on both sides, we need to think about making things equal. Our bases have to be equal. Now since I have both here, the bases are 3, I can solve this problem by setting my exponents equal to each other. So x equals 5. And then I'm done there. Now if I look at a problem that looks like this, my goal first is to have my bases become the same number. So I have to think back and I have to go, okay, what can I simplify this to? What cubed or what to the second power can I have both of these bases to? So if I look here, I can change 9 into 3 squared times 2x, because 3 squared is the same as 9. I can also change 27. If I looked at my perfect cubes, 27 is a perfect cubed, so it's going to be 3 cubed times x minus 1. Now that my bases are the same, right here my bases are the same, now I can set my exponents equal to each other. So I have 2 times 2x equals 3 times x minus 1. I'm going to simplify this, so this is going to be 4x equals 3x minus 3. To solve this problem here, I'm going to subtract 3 from both sides. So x equals negative 3. And if I want to check this, ladies and gentlemen, I can go put it back in and I'm going to get the same answer that I ended with. Alright, so this is what we're going to do when we have exponents on both sides. Now if we have exponents on one side, we have to isolate the base. That's very important, very, very important. We have to isolate the base first, then we have to change it into log form. So here, to isolate my base, I have to get this by itself. In order to do that, I'm going to add 1 to both sides. So I have 2x equals 7. Now, since I've isolated my base, I need to change this into log form. So I have log base 2 of 7 equals x. Now x is all by itself. I'm going to use the change of base formula, so it's going to be log 7 all over log 2 equals x. Once I type that into my calculator, I'm going to get x equals approximately 2.807. And there is my answer, ladies and gentlemen. All right, we're going to do a couple more examples. Make sure you get this example in your note, okay? Also for this one, we have exponent on one side. So first thing, I have to get my base by itself. So I have to get e alone. So first thing I'm going to do is divide by 4. Once I do that, I get e to the 2x equals 5/4. And I'm going to leave it as a fraction. Now that my base is by itself, I need to put it into log form. Since I'm working with e, it's going to be ln of 5/4 equals 2x. Well, now I have to solve this for x, so I'm going to divide both sides by 2. And I'm just going to type all this in my calculator. So I'm going to do the natural log of 5/4 divided by 2. And I'm going to get 0.112 is approximately what x is going to equal. Now once again, you guys, if you want to check, you can plug it back into the original and we should get approximately 5 out. All right, one more example. Here we go, last one. First thing, we have to get our base by itself. So first things first, we have to subtract 1. And we're going to get 3e to the x equals 84. Now we're going to divide both sides by 3. We're going to get e to the x equals 28. Now, since my base is all by itself, I can rewrite it in log form. So I'm going to get natural log ln of 28 equals x. Type this into my calculator, and I get approximately 3.33 equals x. And then if we want to check, we can plug that number back in for x to see if we got the right answer. All right, ladies and gentlemen, that's all I have for you today. So go out, have a wonderful, fabulous, fantastic day, and I will be seeing you later. Bye.